Hello, everybody. Great to see so many people already. It'd be lovely if you could put in the chat where you're joining from, what time of day it is, the age group that you teach, that sort of thing, just so we start to get to know the people that are in the room. We'll wait a couple of minutes. We're expecting quite a lot of people, so it might take a while for everybody to join the meeting. So just let us know who you are while we're waiting. You may be able to see that there's hi Ravati from Sharjah. Nice, welcome. Colleagues from Trinidad and Tobago. Hi, Shalima. You could also let us know if you've been to some of these before as well. If you've been to any of these webinars before. Lots of colleagues from the Caribbean. That's great. Morning, Romain in Jamaica.
Hi, Romain.
Hi, Mark. You say normally teach in Vietnam. Does that mean you're somewhere else at the moment? Hi, Sumi in Muscat. Welcome, Anshal in Delhi. Already got lots of people from all sides of the world. Hi, Sherry. Well, I hope you enjoy it, Sherry. I hope you enjoy your first session and come back for your second one. Okay, whereabouts in England, Mark? Hi, Deepti. Hi, Miriam. Okay, I'm up north. I'll tell you more later. Yeah, in fact, you think you've got worse weather than we have in Maidstone at the moment, Mark. You can see bright sunshine illuminating my bald head.
It's 2:00 now, so I think I will make a start. So hi, everyone. Thank you so much for joining us today and giving up your time to attend this session, the first session of part 2 of our Maximising Maths webinars. So if you joined us in September, we were joined by Tony, Andrew and Charlotte Rance, and this week we'll be joined by Tony and Andrew again. So we've got 4 sessions this week, and this is the first of 4, and we're joined by the lovely Tony Cotton, who some of you might have seen before. Tony's the author of My BZ Math for the Caribbean and Singapore, Max Math Singapore approach. And Tony today will be talking about counting and how you can maximise your maths teaching skills in counting. So place value, fractions, decimals and percentages. So I'm glad that I'm not sure if I will be able to bring any benefit to that really with my maths experience. So Tony is the expert here. So a big thank you to Tony for hosting the session today. Yeah, do let us know where you're joining us from in the chat box. I can see everyone has been saying their hello, so thank you so much. So nice to see everyone from all different parts of the world. The session today will run for an hour, and you'll be sent a certificate and the slides afterwards, and also the recording. So do keep an eye on your inboxes for those as well. And yeah, please do use the chat box throughout the session and enjoy. I'll hand over to Tony now. So see you later on.
Thanks very much, Catherine. And isn't it a treat to be sitting in a little shed in Otley in the north of England and getting messages from Thailand, one side of the world, from lots of colleagues in different parts of the Caribbean, people who teach in different places and are on holiday in another place, and suddenly the world becomes very much smaller. And that's a good thing. I think the more we can all get together in places like this, even if they're virtual places, the better it is for all of us, really. We all learn from each other, and then our kids learn from our learning. So when we were talking a while ago at Macmillan about possibilities for webinars, I was very keen to run some webinars around subject knowledge, around teacher subject knowledge. And I'm going to talk a little bit at the beginning what I mean by teacher subject knowledge, because I think that's the thing that improves teaching. I think our own knowledge of the subjects that we're teaching and of teaching is the single thing that can best improve children's learning. I think I know that because I think the more I learn, and I'm continually developing my own knowledge in all sorts of ways, the better teacher I become. So being a teacher isn't something that you just learn and then kind of stop, is it? We are always developing. We're always, and if we reflect carefully and think about what we're doing, we're always getting better. Um, we may get more tired the older we get, but we certainly have developed more knowledge through our experience, and that developing knowledge through experience is what subject knowledge is, I think. It's very difficult in 4 webinars to cover the whole of mathematics. So in a way, what we're doing is dipping our toes in the water in various places, maybe to start to get that you thinking about your own mathematical subject knowledge. I ran a series of workshops for an international school in Germany a few years ago, um, and we took the whole week over running a whole series of workshops around subject knowledge. And one of the teachers at the very beginning said, "So, do you expect us to suddenly become interested in doing maths for its own sake then?" And I said, well, maybe I do. Maybe I would quite like some people to be interested in doing mathematics outside of their teaching, to develop their interests in mathematics outside of teaching. I don't think it's not everybody's interest, but if some of you will already do that. Some of you will already be involved in doing your own recreational mathematics, we might call it. Maybe if some others of you get into that would be quite interesting. Um, One of the things that I often think in terms of the way that our learners view us is that those of you that teach with very young learners, um, they may not think that there's this thing called a specialism in mathematics. They may know that you have a fascination with maybe art. Maybe you're an artist in your spare time. Maybe you did art at university, and maybe you will then take your art sketchbooks in from your practice as an artist, and that would inspire kids. Maybe some of you are musicians, and hopefully you will then share your musical skills with the kids that you teach, and they will see your expertise in music, and that will inspire them. Maybe some of you have a particular interest in history and a particular period of history. My middle son is staying with us for a few days. He's a nurse. He's 35, and he's just starting a postgraduate course on very early history for his own interest, because he's always been fascinated uh, in early history. That was his first degree before he became a nurse. If that was the case for a teacher, they could share their new learning with the class. Not many of us, maybe I would let me guess at 0 out of 155 people in the room so far, share our own mathematics or mathematics that we're interested in with the kids that we teach. When I go and work in schools, and I still work in schools once in a while, I quite often take in some mathematics that I'm working on. I'll say, oh, I'm interested in this particular puzzle or this particular piece of mathematics, and you can see the surprise on kids' faces when they think, what, this bloke does maths at home? But then that kind of grabs their interest as well. So they see this, they see that there is kind of some kind of sense in that, and that there can be an interest in mathematics, not just something that you have to do at school, usually between 9 o'clock and 10 o'clock, because it's the thing that you do first while your brains are getting warmed up. Sorry, I can sense myself talking too quickly. It's because I've got excited. It's the first webinar for a while. I promise I'll slow down, then you can probably make a little bit more sense of what I'm saying. And one way of me slowing down is for me to ask you a question. And what I'm going to ask you to do is to think about your day so far today. So for those of you in East Asia, Southeast Asia that have been contacting, you've almost had all of your day. Those of you just starting your day in the Caribbean have had less of your day. Think about some mathematics that you've already done. just day-to-day mathematics, some mathematics that you've done in order to maybe organize something. Um, I'll stop giving hints. And just put in the chat um, what that mathematics has been, what you've had to use mathematics for so far today. Hi, Deep T. I'll just check if anybody else can say whether they can hear. I'm assuming people on the whole can hear because you're the first person that's put that in the chat, and we did test it. It may be your machine, in which case maybe leaving and coming back in again might sort your audio problem out. Yeah, and it's something we kind of do every day, isn't it, Mohan? We need to think about where we're going and how long it'll take us. We probably need to think about time of day and notice which times of day travel takes different times. And in itself, that's mathematics, because what we're doing is we're kind of drawing on our experience and thinking every time I leave at 8 a.m., it takes me maybe 1 hour and 15 minutes to get to this place. If I leave at 7:30, it takes me half an hour because of the traffic. And then we can make other judgments from there. Booking a flight, you were using, that's Money Ray. Obviously using particular skills on the internet, skills of navigating the internet, thinking about probably thinking about pricing, thinking about what's cheap and what's expensive. Hi Sumesh. Bagashri, sorry if I've said your name wrong, Bagyashri maybe. I will try to say people's names. There's nothing worse than me not saying names, but I do need to apologise for when my terrible English monolingualism gets in the way of my communication. What were you making a chart for, Molly, I wonder? And shopping for Hana. We use maths in a different way in terms of shopping, don't we? I bought some mushrooms this morning. I'd made some mushroom soup. In itself, quite a mathematical activity. Now I tend to judge amounts rather than have to weigh out, but that only comes from weighing out and noticing what works best. So again, experimenting. Um, when you buy mushrooms in the supermarket in England now, it actually tells you the equivalent price per kilogram for all of the different mushrooms that are on display. So I didn't have to work out for myself what was the cheapest, but that would be something that I could previously do. But I even think sometimes just noticing prices is something that's mathematical. So I know that not everybody, when they're going around a supermarket, looks at the prices of things, or maybe remembers how much something cost before, so will notice whether it's got more expensive. So that has kind of quite a big impact on the way that we live our life. Geraldine's been paying her bills, Molly's been getting to work, lots of shopping. Sumersh, it's always different. Yeah, well, it's kind of within a range, isn't it? We know that it's within a range. Yeah, Mark, we've just got an electric car. Well, we've had it a year now, and it changes the way that you operate, doesn't it? And one of the things I think that happens with electric cars is, or that you can, this is for everybody now, what you get is a range. So you don't get whether a tank is full or not. We fully charged our car last night, and we've now got 250 miles it's giving us as a range. Now, I know that the range can vary between 250 and 320, and it depends on the temperature outside, because batteries run a different efficiency they're less efficient when it's cold. But it also depends on how fast you drive. And whether you have the heating on and all of those sorts of things. So you're actually in lots of ways much more in control of your fuel consumption in terms of electricity. But that can be quite nerve-wracking because you can't just pull into a petrol station to fill up. You have to plan ahead and think where you're going to stop to recharge. Yeah, I guess you do normally ride a motorbike in Saigon, Mark. But yes, I can recommend electric cars. So people noticing lots and lots of mathematics that you've been doing already, and I think that's one thing about being mathematical in your day-to-day life is actually noticing that you're being mathematical. I can talk to some people and they'd say I don't ever do any maths in my day-to-day life. One of the things that I do is edit a journal called Mathematics Teaching, and there's a piece in every month where I interview somebody who isn't a mathematician about the mathematics that they might use in their day-to-day lives, and they're often quite surprised when we unpick the maths that they do. So, for example, the last issue was somebody who's a musician, and I was having a conversation about how much mathematics there is in music, in understanding music, but also runs a coffee shop, but didn't really see that he used mathematics all of the time in the coffee shop, and not just in budgeting to run the business, but in making good coffee. You have to run it for a certain amount of time and weigh a certain amount of coffee out, and you have to get that measure exactly the same each time, or else you don't get a consistent coffee. Now, the thing that I'm interested about in your responses is that most of what you've talked about is around counting and calculating, that we notice that most. And I'll maybe talk about other sorts of day-to-day mathematics that we do on Thursday in the webinar on geometry on Thursday. But most of what you've talked about there comes from counting. So we're in the space where we're counting, and we certainly place value, fractions, decimals, and percentages, I think, all grow out of this ability to count, which is the ability of seeing numbers in a particular order, knowing that something is more or less than something else is counting, isn't it? We're still, and all the different sorts of representations of the number system that we might use are to do with counting. So we can't say 1.7365 without having an understanding of 1 and 7 and 6 and where they come in the number system. Hi, Shinyeri from Qatar. Oh, Jacqueline, that's fun. Yeah, amazing. The amount of mathematics there is in tailoring is incredible. I could talk for an hour about that, but I'll not. I'll just say thank you for putting that there. Quite a lot of you said you've been to my webinars before, so I'll not spend very much time talking about myself. I think you get a good sense of me and where I'm coming from through what I say. Lovely that so many from the Caribbean. Now that we're traveling again, it was very exciting just before Christmas for me to travel with Catherine, who you met right at the very beginning, back out to Belize, which counts as the Caribbean and Latin America, which is great. And that's me in the south of the country, at the end of one of the workshops. I've used that image because I think to me it talks a little bit about my beliefs about teaching mathematics and the importance of subject knowledge. So at the beginning, Catherine said, I worked on the first edition of Max Maths, adapting it from Singapore Maths and reworking it. Andrew, who you're going to meet later in the week, has worked on the second edition of Max Maths. My BZ math grew out of Max Maths, was a rewriting of it for the new Belizean curriculum. I worked on materials for Jamaica, Explore Mathematics, the Explore Mathematics books for Jamaica, and underpinning all of those resources for teachers teaching children in schools is my belief that we learn subject knowledge best by teaching. So I believe that by writing books that you will use for kids in school, the kids that you're working with, you will develop your own subject knowledge. You will notice things about the mathematics that you didn't maybe understand before, or maybe hadn't noticed before, through the teaching of the mathematics. And I think something I was trying to share with those beautiful teachers in Belize was I was trying to develop their subject knowledge rather than just tell them how they might use a book. because by developing subject knowledge, we end up having more control over the content that we teach. We have a better understanding of it. Maybe we're better able to move away from the content that we've got in front of us. Maybe we can be more flexible with the content because we're more confident about the mathematics ourselves. So one of the things I was hoping to do with those teachers in Belize, and we worked across the whole of Belize over 5 days, was develop their confidence in their mathematics, as well as their confidence in themselves as teachers. I think those two things go together. You will have different amounts of confidence depending on the subject that you're teaching, I guess. So there will be subjects that you feel comfortable teaching. There will be subjects that you get excited about teaching. And there will be subjects that you're more nervous about teaching. And I often, when I'm talking to teachers, will say, well, think about the subjects that you are excited about teaching. The subjects when you're not concerned about the planning because you know you're going to be able to teach it. Maybe subjects that you're happy to be a bit more flexible in it. And what is it about those subjects that gives you that confidence? And how then can you transfer that confidence over to subjects that you feel less confident in teaching? So if you're less confident about teaching mathematics than other subjects, think about that subject that you're really confident in and reflect on how you could maybe develop that sort of a confidence in your own mathematics teaching. So subject knowledge in mathematics isn't just about being a good mathematician. In previous webinars, we did all of that stuff about what makes a good mathematician. This isn't just about being a good mathematician. Some of it is, and maybe that's in terms of a confidence, thinking I can do mathematics. You could probably hear in Catherine's voice at the beginning, I don't think I would be able to do this. I know she could, because I spent 5 days in Belize with us. So I know that she's quite capable of doing any mathematics that we wanted to do, maybe with support and maybe through conversation and maybe through being motivated to do it by somebody. But I always say to people, if they are not confident in mathematics now, or if they've had a bad experience of mathematics at school, that doesn't mean they're bad at mathematics. It means they had a bad mathematics teacher. Any of you and all of you can be, are, will be good at mathematics. And now, from now, you can have the best teacher teaching you mathematics because you can have yourself. That wasn't going to be me. Okay, you can have yourself teaching yourself mathematics, and your other good teachers will be the kids that you're teaching that you can notice doing mathematics. But that's only a part of subject knowledge in teaching mathematics. So as important as it is, it's only a part of it. Another part is this thing called pedagogical knowledge. And that's how you teach particular things in mathematics. So that when you come to plan a specific lesson, what you have is a knowledge of different approaches that you could draw on to teach that lesson and which ones have been most successful in the past, which are most appropriate. So you're selecting from a series of different strategies. So that's having an understanding there's not just one way to do something, that as a teacher you have choices to make and that you can take control over those choices so that you'll make a good choice when it comes to teaching the mathematics. And you'll notice I didn't say the right choice then, or you may have noticed. And that was deliberate because I think there are probably always several choices that we can make which will lead to effective learning. And sometimes we make choices which don't lead to effective learning. That doesn't make us a bad teacher. It doesn't make our learners bad learners or bad at mathematics. It just means we need to think about how we might do it differently so that the next thing we work on is more effective. Hi, Antoine. Greetings from Jamaica. I wonder if you're Ant for short sometimes. I'm Ant for short sometimes. Hi, Kashaliani from Qatar. Has it got a bit quieter in Qatar since the World Cup left. And hi Carleen in Manchester, Jamaica. I'm going to Manchester, England on Friday. So mathematical knowledge, pedagogical content knowledge, contextual knowledge, absolutely vital. That is your understanding of the context in which you teach and the children that you're teaching. And without that knowledge, you can't be an effective teacher. So you can have all the mathematical knowledge in the world, you can have all the pedagogical subject knowledge in the world, but if you're not noticing the particular context that you're teaching in and the particular needs of your learners, then you won't be an effective teacher. And then the last of those four is an understanding of the curriculum that you teach. So all of you here will be teaching slightly different curricula. And I know for a fact, because I've worked in the Caribbean, that there are several differences between a Caribbean curriculum and a curriculum in an international school in Singapore or in Thailand, for example. So in the Caribbean, there's a lot of work around set theory from very early on, which doesn't take place in other parts of the world. That doesn't mean one is right and one is wrong. It just means we're looking at different parts of mathematics. But if I'm a teacher in Bangkok, it might be questioned if I suddenly spent a lot of my energies teaching set theory to my grade 5 students. It wouldn't do them any harm because it's interesting and useful, and I could get all sorts of mathematics out of it. But you can imagine somebody might say, "But why are you doing set theory and not covering something that's in the curriculum?" And similarly, if I was teaching in a school in Jamaica and I started covering fractions, and in the Singapore curriculum, fractions are dealt with later than they are in Jamaica. People might say, well, why haven't we taught fractions yet? All of the other kids in the other schools are learning about fractions at the moment. So I need an understanding of the curriculum. That's another piece of knowledge. So that's what I mean by subject knowledge. It's all of those things. You will, Nirmal, you will get a certificate. Only another 34 minutes to go, and then that certificate will be winging its way through the post. So try and keep all of those things in mind. And what I'll be doing in the rest of the workshop is thinking about knowledge of mathematics and pedagogical content knowledge. So thinking about your own mathematical knowledge through the teaching of mathematics. And then it's your job to put that into a context, and it's your job to relate that back to your curriculum. I can't do those bits for you, but you can do those very, very effectively. Now, some of you may have seen this slide and heard this story before, but I want to come back to it because I think this is at the heart of counting. Excuse me, I'm just going to turn my heater off because I'm getting very hot. It's actually -2 outside, but so I had my heater on in my shed, but it's got to more than -2 in my shed at the moment. Counting, I think, is something that we often see as straightforward, and people who can't count, we think, oh, well, why can't they count then? That everybody can count. And maybe we oversimplify it. Maybe we think it's really straightforward. We don't think very much about kind of the theory or how we might teach counting. And I think that's partly because we can't remember learning it. I can't remember learning to read. I could read by the time I went to school. I was quite a solitary soul as a younger child, so I read a lot. So it's good. Being solitary worked out for me because I read a lot. So I can't really remember learning to read. I can just remember reading. Counting, it's the same sort of thing. We could just count. I'm very, very, really fortunate. I've now got 4 grandsons. They're all male. And they're teaching me a lot about learning to count, about learning mathematics. They're teaching me a lot about how different individual kids can be in terms of the way that they learn. So they're teaching me all of that contextual subject knowledge, or allowing me to notice that, and then I can apply that across other learners, and I can apply that in my writing. And that's Quinn. And he is at the very beginning of learning to count. So I think he's about 18 months old in that photograph. I'll just quickly run through those 5 principles. You may know them, you may not have come across them, but those are 5 principles in terms of learning to count. They don't go in a particular order. I think there's often there's kind of a propensity in theory, isn't it, to pretend that things always go in a particular order, and they don't always go in a particular order. And actually, all of those 5 principles can be learned simultaneously, or we can select one of those principles to notice and to work on. But by the time we've learned to count, we have an understanding of all of those principles. So the one-to-one principle is understanding that you only count each item once. Sounds fairly obvious, but you will all have noticed children not doing that. So Quinn isn't counting using number names yet, but you can imagine him counting those dominoes and going 1, 2, 3, while he touches another domino, 3, 4, 5, well, he touches another domino, 6 when he touches another domino. That's because he hasn't got the one-to-one principle yet. And that's why we model that action of counting very carefully to young learners. Stable order principle is the understanding that number names always go in the same order. Sounds obvious, but why would that be obvious to an 18-month-old, or why would that be obvious to a 3-year-old? That there's a set of words that we always say in exactly the same order when we're doing an action called counting, because that doesn't apply to any other words. That's why we count and count and count again. That's why we repeatedly count things. That's why we count forwards and backwards, so that kids can get into the rhythm of that. The cardinal principle is why we go 1, 2, 3, 4, 5 and raise our voice on the last number. So we touch each item, and when we say touch the last item, we emphasize that number because that gives us the answer to how many. So 1, 2, 3, 4, 5. That means there are 5 there. Abstraction principle means we can count anything. We could count girls in the class, count boys in the class, can count everybody in the class, count teachers in the school, count children in the school, count them all together. We can count all sorts of different things. And order irrelevance means that we can count things in any arrangement. That's why you'll notice young kids, so if you were to put 5 things in a line, they would count them and say 5. And if I shuffled them up and made them so it was 2 2s and a 1 and said how many are there now, they would need to count them again just to check. So we've been through those principles before, so that's kind of a recap. Now the point of that picture is Quinn asked for those dominoes. He didn't say dominoes, he pointed. He hasn't got the word for dominoes yet. So he's not got language yet, but he's doing mathematics, because when he got those dominoes, you can see that he's starting to arrange them. He's noticed us playing dominoes, so he's making those patterns that he's noticed. That's mathematics. He's seeing how many he can get across the high chair. That's mathematics. He was getting frustrated when he couldn't quite fit them in. That's mathematics. As he was doing that, he was going, e, I. And it was always that rhythm. E, I. Almost like a song. That's him beginning to understand the one-to-one principle. That's the start of it, isn't it? Because he's knowing about an at the end. That's him beginning to understand the stable order principle, because you always say the same thing. I. So that's the beginnings of learning to count. And I think it's important to remember that these things begin by noticing other people doing it. So by the time that children come to you, they will have noticed a lot of other people doing mathematics. And what you can do is build on that. But what you need to do is give them the space, in this case, to be counting, so you can hear what they're doing. So your subject knowledge in terms of the mathematics is having an understanding of those principles, and that's pedagogical subject knowledge. You all know the order that numbers come in. That's not to worry. You will be fairly confident in that order. But you bring your pedagogical subject knowledge to bear on that. And then you bring your contextual knowledge through listening to the kids and having an understanding of what might have gone on before. So that's one part of learning to count, and that's at the very beginning of learning to count. And again, we've talked about concrete pictorial abstract before. So in a sense, this is the next step on from what we were just talking about with Quinn. So he's beginning to develop the concrete stage. So he's starting to count by touching. He's starting to notice what happens when you manipulate, in this case, dominoes, to fit them all along a side. He's modeling that counting rhythm, but he needs the actual objects to touch. He's not yet beginning to think about how he might write that or draw that or how he might represent that. And he's certainly not at a stage when he might be thinking about abstracting that experience. So this little diagram, and again, we've looked at this before, but it's worth coming back to in this context, I think, in terms of thinking about the development of counting, and what's happened before we get to the stage of thinking about percentages and fractions and all of those sorts of things. This comes from an experiment that an English psychologist called Martin Hughes did, building on the work of Bruner, which built on the work of Piaget. So even this doesn't happen overnight. This is something that people have been observing for a long, long time. And Martin Hughes did an experiment, and he had young learners in, and he said he put 5 cubes in a box. He closed the lid on the box. He opened the lid and let the learners look inside. He took 1 cube out, he closed the box, and he said, how many cubes are there in the box? That was the experiment. And then he asked the learners to draw what they'd seen, or to draw something that would help them solve that problem, help them tell him that answer. Isn't it funny? I'm just noticing there's 199 people in, and hey, there's one more. We've gone up to 200. Doesn't that suddenly feel like more than 199? Maths is weird in that way, and now there's 201. Sorry about that. I got distracted. So at he suggested there's this thing called a concrete stage, and that is that you literally draw what was happening. So you can see the 4 cubes in the box, taken 1 out, and I can count the 4 cubes that are left in the box. I need that. That's a concrete approach to that particular problem. Pictorial doesn't mean drawing what you saw, which the first one is. It means using a drawing to help you with a calculation. So there aren't any cubes there. There are 5 lines to represent the 5 cubes, and cross 1 out, and I can see there are 4 left. If it's abstract, we know that a way to represent that problem is 5 subtract 1 equals 4. That bears no relation to this particular problem. It's abstract because it can refer to any problem where we've had 5 things and we've taken 1 away from it, and the answer is always 4. And that move to pictorial is where subitizing comes in. So just quickly have a look at that image on the left-hand side of the page and write in the chat how many things you saw there, and maybe quickly how you did that without counting. I'm glad that happens, Valerie. I'm glad you always learn something new. I always learn something new as I'm doing it, because I start thinking about things. And how did you get 11, Mark? What did you do? And somebody else put what they saw and how they did it. I'm interested in how they did it. There's a few 12s coming up. I'm also interested in how you. It looks like you miscounted then, Mark. How might you do it without counting? How could you do it quickly? So Tishana counted in 2s. Now there's a Jacqueline counted 1 shape, so that's 6, and saw that yes, and Summy did the same. Some people saw 4s, so there's 2 4s, which would be 8, and then maybe 9, 10, 11, 12, or saw a 2 atop of the 2 at the bottom. But you can see that in any number of different ways, can't you? And that is still counting. So counting doesn't just have to be going 1, 2, 3, 4, 5. What we then want to be able to do is notice patterns and count in 4s and count in 4s and add on 2s. And that gives us confidence in terms of our numbers. And that's often a thing called number sense. Yeah, so we're seeing symmetry there. And that's making connections across different areas of mathematics, isn't it? And making connections across different areas of mathematics is a sign of somebody who's confident in mathematics. So seeing that symmetry and using it is being skilled at mathematics, is bringing that skill together. And a way that we've used that in Max Maths is the page that you can see on the right. There's both images of actual objects that you can count. So they're concrete images. So I could actually use the page to count if I wanted, or I could have concrete images. I could literally count those dinosaurs by touching them and count that there are 6. There's an image of those dots in what we would call a 10 frame. So I can see that 6 is 5 and 1, 7 is 5 and 2, 8 is 5 and 3. So straight away I'm getting an image of 6 in 2 different ways. And also, if you think about it, even the arrangement of dinosaurs shows me that 6 is a 3 and a 3. So I'm getting what's called a number sense just from looking at that image. And we could think of how many different ways can we arrange those 6 dinosaurs? What different patterns could we make? And that develops our number sense. So there's our mathematical knowledge being developed in concert with the students as they arrange those dinosaurs in different ways. And we have 2 versions of abstract, one version being the digit and one version being the word. And if I was working in some of the classrooms that you're working in, so if I was working in a classroom in India, I would also be using the script for that number. So because 6 in Bengali is a different script, and the number name in Bengali would be different, I would be bringing those things together. That's my knowledge of context, because you want your learners to be developing their mathematics multilingually, not seeing mathematics as outside of their multilingual skills. And another couple of examples there that I'll not stop at this point. I was going to get you to do that, but maybe if you're interested, you could come back to this when we finished and the video is available. Hi, Donna Marie, in Portland. Working that out without counting. Now, one of my interests on the left-hand side one is that I can see 5 arranged as it would be on a dice. Children who enjoy board games become quite skilled at subitizing. That's why playing board games isn't a bad thing to be doing in a mathematics classroom. And how might you count how many dots there are in that pattern? And one way that you might do that is by a subtraction. You can see how many dots are missing. Once you see there are 10 dots around each side, you have a sense that there are 100 dots altogether. So we're probably great. Thanks, Garuv Kumar. I wonder where the emphasis is. Thanks for that. I'm guessing that you type in how you did that, then everybody can see. That's maybe And there's a kind of joy, yeah, 5 by 5 missing. So, and wouldn't it be quite a nice activity to do with students who are working on percentages to develop those dot patterns for each other, so that if what would 70% look like, what would 65% look like, and so that you can take regular patterns out. Here's another progression which comes from New Zealand. So they have this idea of pre-counting. I get quite frustrated with the idea of pre-counting. I get frustrated with the idea of pre-anything. When I work in universities, sometimes I'm invited to go on courses just before the official course starts, and they're called pre-induction. And the first thing I always say to the students is, the minute I start talking, this is induction. So I talked to you about what Quinn was doing, and you'll notice I said early counting. So I'd rather use a term early count. I think the minute you start to think about learning to count, you're counting. But in New Zealand, it's the idea of more or less. So you're comparing sets. You know whether you don't know how many there are in each set, but you know there are more in some and less in others. And maybe looking on number lines and seeing more or less on number lines. Moving to one-to-one counting, moving to counting how many there are in sets, moving to counting to solve problems, so you can combine sets and count how many there are all together, moving to using number lines to solve problems. I'm not going to go back to, there's a story around that photograph, which is Tate, who is teaching me a lot about the next stage of learning to count. But you can see there that he's starting to develop a sense of place value, because he's able to put those numbers in order. He's used 100 square to help him put those numbers in order. But what he doesn't know yet is that 81 is the same as 8 tens and 1 unit. Now, I kind of thought he might need to know that first, but he didn't. He could solve that problem using a 100 square without having an understanding of place value. My confidence in mathematics subject knowledge, and maybe my age in terms of having seen lots of kids learn to count, knows not to worry about that, and that now he does understand. So this is a year ago I took that photograph about place value, about tens and ones, and I knew that would come, and I knew it didn't have to come first. And you can see that he's not even, he's written 1-5 instead of 5 when he was talking about spelling numbers at that stage, and he was only just able to form his numbers, but he could do quite complex calculations, if you like. He could order numbers between 0 and 100 without being able to confidently form those numbers. Now, if I'd have said you can't do that until you can form your numbers accurately, he would have missed out on a lot of mathematics learning. A colleague of mine called John, I've forgotten his surname, it's suddenly gone, I'll come back to it in a minute, once said, we learn from experience. What we don't learn from experience is how we learn from experience. And what he was talking about is noticing things. So we just feel as though we learn from experiences. The way we learn from experience is by noticing things that have happened and drawing on those later. And he also said, children don't seem to learn in straight lines. So there is an example of somebody not learning in a straight line. So why do we teach in straight lines? Now, I think if we've got confidence in a subject, and when we develop our mathematical subject knowledge confidence, we're more able to not teach in straight lines. We're more able to notice things like Tate having an understanding of ordering numbers to 100 before he confidently forms numbers. And we don't worry about that. We don't worry about that not being a straight line. So representations that you might use, and now we're kind of coming to pedagogical subject knowledge. One of the things that are incredibly useful in maths is giving learners and giving ourselves representations of the number system. And some of those representations are useful in carrying out a calculation, and some of them become more abstract. So even in representations, there's a move from pictorial to abstract. John Mason was the name I was trying to think of. So on the left-hand side of that page, there's a Max Maths page, and you can see that there's a number line, and by counting on that number line, we can carry out the calculation 4 plus 3. Or we could use concrete materials, and we could have 4 cubes to represent parrots, add another 3, and add how many are there altogether. So that's a representation that helps us with a calculation. The one on the right-hand side is more of an abstract representation. So what that does is help us with the recording. So I can see there that there are 9 flowers altogether, and I can make 9 up from the 3 in the vase and the 6 outside the vase. And then that gives me a family of calculations. It's called a part-whole diagram. Now that doesn't necessarily help us with the calculation, it's more abstract, but it helps with the representation. It moves us from that picture to a different form of representation. And from that I can say that 9 minus 6 is 3. I could say that minus 3 is 6, or that 6 plus 3 is 9. Other representations. I think the 100 square is an incredibly powerful. If I could only have one thing, I would probably have 100 squares that I could work with, because I think it gives us a really useful representation of the number system, and gives us different ways of looking at patterns in the. We notice that all of the tens have a 0 in the ones place. We notice that all the even numbers are spaced out by all of the odd numbers. But that is more abstract than using place value materials. So you can see 27 there is 2 tens and 7 ones. If I move on to using place value counters, you can quickly see there that 362 is made up of 3 hundreds, 6 tens and 2 ones. So it teaches me about place value. It gives me an image of place value that can move to the abstract image on the right hand side. But there aren't literally 100 of each of those. And on the right hand side, there's a place value grid, and then there's a representation of the place value grid using counters, again using an abacus. So 6 different representations of the number system, all of which are really useful, and all of which will help students come to an understanding of place value. And I'm sure, Andrew, tomorrow we'll talk about how you can then move from that to calculating, so that calculating doesn't start off as an abstract idea. It starts off by manipulating concrete objects. Those of you that are lucky enough to teach in multilingual classrooms, I do think that using number scripts in different languages, in different scripts, is useful, because it makes us notice something about the number script in Hindu Arabic. So the script that's sometimes called Western, sometimes called European, sometimes called normal, obviously it's only normal depending on your context, developed from Hindu and Arabic scripts. The page there is got a Bengali 100 square on it, and I deliberately use those sorts of scripts to start to notice something about the 100 square that we're asking children to work with. And noticing is a good way of learning things, isn't it? You've escaped this one, you'll be pleased to know. So even when we get to looking at big numbers, and this is from grade 6, level 6 in Max Maths. So there's a number there represented in a place value grid. 3,607,106. It shows that that's made up of three lots of 1,000,000, 6 lots of 100,000, and so on. The 0 is important because it means there are no 10,000s. We can't just miss the 0 out. We get a different number. And if I was to ask you to start counting up and back in 100,000s, 10,000s, thousands, you would find some of those easier or more difficult than others. And I might ask you to come back to this little section and try that out and notice the different patterns that you make. So counting in millions is the easiest. 3,607,106. 4,607,106, because I'm just adding one onto the millions. If I was to say count in 10,000s, that might be a bit, I have to say 3,617,106. 3,627,106. So I can notice what I'm adding each time, and that's a way of thinking about place value. I'm noticing which value I'm adding each time, and I notice what's going on at the transitions and the changes I have to make. So a question to your students might be, what changes and what stays the same? So if I count in millions, what changes is the million digit. Everything else stays the same. If I'm counting in hundred thousands, what changes is the 100,000s. What stays the same is everything else. What about counting in 500s? What about counting in fives? So just an activity like that is incredibly rich in terms of what you might notice about place value. I deliberately put that slide in because one of the things that's a little bit different about the Caribbean curriculum, and we're working in Belize, is thinking about binary in primary school, thinking about base 2. And I started the section in those maths textbooks with that joke, maths joke. There are only 10 types of people is how most people read it. Those who understand binary and those who do not. Well, 1 0 in binary means 1 lot of 2 and 0 lots of 1. So 1 0 is the same as 2, which was the joke, if you like. And I think binary is quite useful in terms of noticing what happens to our place in the base 10 place value grid. So most students leave school. Most people I know, maybe most of you, either don't know or forget that it's called base 10 because there actually were lots of other options about bases that we could work in. But going up in powers of 10 across the place value grid is just the most straightforward way of organizing numbers. Binary, the columns are 1, 2, 4, sorry, that should be 8 and 16. That's an error on the slide. So it's 2 to the power 3, which is 8, 2 to the power 4, which is 16. In base 10, it's 10 to the 0, which is 1, 10 to the power 1, which is 10, and then 10 squared is 100. 10 cubed is 1,000. Sorry, I've gone all over the place on this slide. And 10 to the power 4, which is 10,000. But it's another way of starting to notice what's correct, how we've kind of structured our place value grid. Now I'll give you 2 minutes to think about this. If it's all right with you, I'm going to go 5 minutes over. Too much to fit in, but I do just want you to think about that as a question. A half is always bigger than a third, true or false? Now I'm taking that. Okay, true. Okay, Jacqueline, write a little bit more about what you mean, Jacqueline, because you're the only one who's written anything apart from true so far. Okay, so Jacqueline said image size. I'm interested in knowing what you mean by image size, It's one of those things where it would be okay. So abstract true, concrete false. So yeah, Mohammed's not able to share it, but we could draw an image where a half of one image was smaller than a third of another image. A half of 50 isn't bigger than a third of a million. So yeah, Radhika explained it better than me. Depends on the size of something. It depends. So that's deliberately there for us to think about, not always taking things at face value, if you like, even in mathematics. So a half isn't always bigger than a third, but a half of the same thing is always bigger than a third of that same thing. And I quite often use that statement at the beginning of a lesson on fractions with students. Another thing that I would do is give them a piece of paper and ask them to fold it in half, usually a square. Yeah, face value will fool you sometimes, Jacqueline. And then I'll say, can you make a different half by folding it differently? And that can be quite challenging because it feels as though they've done the question by folding it in half one way. And then of course there's any number of ways that you can fold something in half, but the areas have always got to be equal. So what we do by not taking that at face value is get closer to the actual mathematics that's important, to the big idea, which is that equal fractions have to have equal areas. So a half of a shape has to have an equal area to the other half. And we're back to thinking about images now and different representations. So we can represent fractions on number lines in the same way as we represent numbers. So that's a progression from counting, is thinking about where do fractions go on a number line. So we're back to counting on a number line, and then those images give the idea of equal areas. Or we can use bar models, which are another form of number line. And these are all pages from Max Maths. Somebody actually said that to me once, thinking about percentages, and you saw how percentages and counting were linked with that image earlier on. I got 80%, Mr. Cotton, but how many did I get right? So, and what I could then do was use that lesson as a lesson teaching about percentages, which is what I did. And we did lots of questions like that. So just looking at that second question, I got 78. My friend got 15 out of 20. Who got best? Just put an answer in the chat, and how you knew, how you worked that, how you knew. Who did better, the person that got 78% or the person that got 15 out of 20? Fayan said the person that got 15 out of 20. How did you know, Fayan? How did you know, Mark? So Mohammed said, I think that says 78 is greater than 75. How did you know? Colleen, tell me how you knew 78% was better. Or Nazek, anybody, any of you that's saying 70. Brilliant, Mark. So 15 out of 20 is 3/4, which is the same as 75%. So can you see there how what you did was bring together fractions, percentages, and all of which is developed from counting. So fractions and percentages and decimals are actually different ways of representing the same sort of idea, all of which grow out of counting. I think that's probably sufficient. I'll just quickly talk about that from rounding. Just making the link again that rounding comes back to counting, because one of the ways that we can teach rounding, or that I always teach rounding, is using a number line and the two boundaries, because the rounding shows you when the arrow is nearer one end of the number line than the other end of the number line. So the two possible choices with the number we're trying to round in the middle, and then we can see where to round it up or round it down. And there's this kind of assumed truism that we always round up from 5. We tend to round up from 5, and in primary school we will teach always round up from 5. If we're statisticians, we don't always round up from 5. We alternately round up and round down from 5, because that gives us a better average. But we could talk about that another time. You can maybe think about why that gives us a better average. So I'm going to stop there with another example of a number line and how decimals, we're just counting in different ways when we're doing decimals, and we're still using number lines and the kind of power of a number line in helping us to count. And say thank you very much for joining in. Apologies for going 5 minutes over. I could talk about this sort of thing all day, as you've noticed, but I'll behave myself and stop. Thanks, Catherine.
Thank you, Tony. That was brilliant. Thank you so much. I think everyone can see that you're very passionate about maths, which is really amazing. So thank you so much. I hope everyone enjoyed the session. I can see lots of thank yous coming in. So thank you very much. It's been so great to see people from all over the world, as always. So yeah, brilliant. So just a bit of information that you'll all be sent the recording of the session, a certificate and a copy of the slides following the session. So do keep an eye on your inboxes. We have 3 other sessions taking place this week at the same time on Tuesday, Wednesday and Thursday. So please do sign up for those if you haven't already. And Tony will be joining us again on Thursday.
Yeah, looking forward to it.
Yeah, so thank you so much again, everyone, and thank you very much, Tony. Enjoy the rest of your days, evenings, afternoons, and hopefully we'll see you soon.
Bye, everybody. Thank you.
Bye.